started. Let's let that load up there. Okay, so for number 2, so the idea here is if it's tangent, and we don't know that yet, but if it's tangent, this is a 90-degree angle, which makes this a right triangle. Okay, so the question is 6.6 squared plus 11 squared equal to 13 squared? If it's tangent, then this will be the case. All right, so you have to check the left side. You have to square 6.6, square 11, square the right side, and they have to be pretty close, like basically, on. So on the left there, 6.6 squared is 43.56 plus 121 equals 169. On the left, this adds up to 164.56. So this is not tangent. You would say AB is not tangent.
So they have to be like really, really close.
Or exact, which is what we hope for. Okay, so let's look at one that actually is. Let's look at number 3.
1 second.
Sure.
Okay, so let's go to number 3.
Okay, we will come back to 1. So if it's okay to draw that in as sort of a suggestion, like you hope that it's a right angle. You can even redraw the triangle like I'm doing. So is 12 squared plus 16 squared equal to 20 squared? Is that true?
144 plus 256 should equal 200.
400.
Or yeah, 400, sorry.
Yes. Does that work?
It does.
It does. Now, sometimes when you see one that works, you're thinking, well, should I have known that? Was there a way to know that ahead of time? There are certain Pythagorean triples which are good to know. These are numbers that always work: 3, 4, and 5, 5, 12, and 13, 7, 24, 25, 8, 15, 17. So this list actually goes on forever. You should know them, meaning like it's better to know the first one than the last one. It's better to know the first 2 than the last 2, and so on. But you can see, like, well, hey, Matthew, these aren't 3, 4, 5, 5, 12, 13. Yeah. Well, if you multiply the first one times 4, you get 12, 16, and 20. And if you multiply or divide them by the same number, it also works. Now, you don't have to do that. You don't have to even know that, but it is a shortcut for this. Okay.
Yeah.
All right, so let's go back and look at number 1. Good question.
These Pythagorean triples, do they work in like in reverse? Like, could I do like
you can
like
multiply
20,
or divide
16, and 12 divided by
yes
a number to get. Okay.
Yes. So like one I like to give is like 3 sevenths, 4 sevenths, and 5 sevenths. That actually works, believe it or not.
Okay.
Right. You guys have studied triangles already? Yeah, because you gave me some right. Yeah, I mean, you should have, like, this should have been shown to you. Maybe it wasn't made like clear, but it should have been given. So anyway, I mean, this is a small point. Now, let's go back to number 1. The reason I didn't do number 1 first is because they're kind of showing this a little bit awkwardly. They're putting 8 and then 12, okay, here. And you're supposed to know now that you can add them up. 8 plus 12 is 20. What is this other length right here? And you're not using the Pythagorean theorem. It's given in the drawing, but maybe you need a reminder.
It's gonna be or it's the radius.
That's right, and the radius is 12.
12, yeah.
So if you need to, sometimes it's good to come off to the side. Is 12, 16, and 20 is 12 squared plus 16 squared equal to 20 squared. We just did that. Yes, it is. All right, so I'd like you to try number 4 on your own. Whenever you're ready, no rush, but give me a, yes, no on whether it is a right triangle or not.
It is.
Yeah, believe it or not, it works. It's like sometimes you can't jump to conclusions.
Yeah.
You gotta work it out and see. So you see these on standardized tests, things like the SAT, ACT. I do SAT prep, ACT prep if they're ever an
Mhm.
interest. Okay, so any questions on that before we move to 5?
Nope.
Okay, let me just look at this grouping. All right, let's actually. Wow, they're really, really super repetitive. All right, we'll just do them in order because you've already seen right triangles. This should not be too
Yeah.
new to you. The circle in some ways is a distraction. Like it's almost better
Mhm.
to just not draw it all together. They're telling you that if it appears to be tangent, that it is tangent. So you can assume that this is a right triangle, and
Right triangle.
you're literally just finding the missing leg. So as a reminder, a squared plus b squared equals c squared. A and b are the legs. They come out from the 90 degrees. The order doesn't matter. C is the hypotenuse. It is opposite the 90.
Mhm.
Okay. So in this
Yeah.
problem, it's 4 squared plus b squared equals 8.5 squared. Go ahead and solve that for b, please.
7.5.
It is 7.5. Good. All right, let's look at 6. 6 here. All right, so this one's kind of like 1 in the previous
Mhm.
grouping here. That's 90 degrees. What is the length of the hypotenuse of this triangle?
2.5.
2.5. What is the other side? One of the other sides. Can you visually tell me?
1.5.
1.5, right? So it doesn't matter. We'll call it A this time. A squared plus 1.5 squared equals 2.5 squared. Do you mind solving that for us, please?
It's 0.25. Or
Try
no,
again.
sorry.
Try again. Try again.
Yeah.
You violated the one of the triangle length
Yeah, I didn't
postulates with
square
that answer.
2.5. 6.25. Sorry. So 6.25. X is 4. Or the missing length is 4.
It can't be 4. Can't be larger than the hypotenuse. So what have you
Oh,
not
oh my
done?
gosh. Squared it.
Yes.
2.
2. Yeah. And if you again, this is a Pythagorean triple. It's a 3, 4, 5. It's kind of like what you were asking me earlier. If you
Mhm.
divide them each by 2, you get that. The previous one was also Pythagorean triple. It's the 8, 15, 17. There's some shortcuts
Oh
there,
yeah.
especially on standardized tests that you'll see. All right, why don't you try 7 and then maybe 8 on your own. 7 we've done 3 times now, so maybe you can just tell me the answer.
Mhm. It's Gonna be 200 or 12 or sorry, 20.
20, yes. If you need to show work, you may have to put in a little bit more than just the answer.
Yeah.
I would find it very, very, I would actually enjoy a student saying, we already did this one and one and, 3. So that's my work. But
I'll write that. I'll write that.
yeah, see if the teacher has a sense of humor or not.
So 12 squared. $13.6 per 8.
13.6. Yeah. Now this is also a Pythagorean triple. It's a pretty large one. If they're all whole numbers. So if you have to figure out, well, what do you multiply by to get back to a whole number? In this case, I think it's 5. So it's 60 on this one. And then this one is 32. And then this one would be 68. But then I think that means they all could be divided by 2.
Oh
So,
yeah.
so this is actually a 30, 16, and a 34, which means we can divide it again 15, 8, and 17. So you can play some game. I mean, it depends how interested you is, and no judgment if you're not, but it's like there's
Mhm.
there's things here. Okay, let's look
Yeah,
at
there's.
sorry for interrupting. What were you gonna say?
Oh, I was just gonna say that it's kind of like shortcuts for the problem.
It is. It really is. Unlike the stoichiometry where there are no
Hmm.
shortcuts. Okay, these are called walk around problems. And you start in some place. Usually you start with known information. Like for example, we can either start at 10.5 or 11.2. Are you drawn to either of those?
10.5.
10.5. So the idea is that these two are congruent. These two segments that I've shown are congruent. Um,
Okay.
that's something you would have seen in class. We can talk about it if you want.
How
But
did you
that
how,
means,
how do you know they were congruent? Because I don't think we did that.
yeah, it's like if you try to get, so there's sort of these 2 points equidistant on the circle. And so if you try to get to either of them, it takes the same distance to get there. Um,
Oh yeah.
it comes from though the fact that these meet their tangents, so they make a 90-degree triangle, and then they meet a 90-degree triangle.
Oh
So
yeah.
you can you
That.
can you can prove congruence here. You might have even done that earlier in the course. You prove the triangles are congruent, and then these are congruent. You don't have to do all that now, but that is what you're
Hmm.
doing. Now we can't go any further. We're kind of stuck there. So we go back the other way. If this is 11.2, then this is also
Oh,
11,
also
11,
11.3.
which means we can find the other segment, which is 11, 12.13. How about 13? 13.0 or 13 or 12, if I can add. It looks like it's 12. Okay. And then again, by symmetry or by congruence, sorry, this one's also
That's also
12.
12.
Yeah. So
So
these
then 10.5.
and there's nothing left to do. It does ask for the perimeter, so you have to calculate that, but there's no more calculations once you find
Mm-hmm.
all the line segments.
Cool. So.
A small shortcut here is to double each of the 3 numbers like this, add them together, then double. It's a small shortcut.
Oh yeah. I got 67.4.
All right. Is this graded like for um is this graded like do you have to get the right answers or
Mm-hmm.
okay, let me just double check. I didn't calculate that one. All right, very good. Okay, now sometimes they give you units. Apparently they didn't in this problem.
Yeah.
Sometimes they do, so keep that in mind. All right, this one kind of same problem here. You start, with known information, sort of move in the direction of the known stuff. So that's 4.6 up there, 13 and 13. This one is 12 and 12. And then you can find the last one here, which is uh, 9.8 and 9.8.
How'd you get 12?
From this is 13, and then the whole length is 25.
Oh, right.
You're subtracting from it. Good question. So a lot of numbers. I mean, sometimes it's good to actually just draw in the outer, like I did in the previous one. Is just redraw. It's like this is 25. This is 21.8. This is 17.6. This one is 9.8 plus 4.6, so 14.4. Up to you. Sometimes less is more.
I got 78.8.
I got 78.9. Did I make a mistake? Let's see here. 13, 17.6, 25, 21.8, 10.4, 14.4. Should be 0.8. So I made the mistake here. Yes, I did.
Oh,
78.8. Okay.
cool. There's
All right.
another this one. The 14s are congruent.
Yeah, so notice if you do that one first, you got you're kind of stuck. You got to go back the other direction and
Mm-hmm.
get this other one is 9. 23 minus 14 is 9. 9 and 9.
Mm-hmm. 22.7 minus 9. 13.7. Uh, 73.4.
That's what I got as well. Very good. All right, so last one. Maybe much easier than they initially appeared. That you
Mm-hmm.
know how to sort of walk around the polygon, quadrilateral.
Ooh,
Question?
how do we get the number next to 5.4?
You're subtracting from 18.4.
Or no, 13 I got, but
This other one on the
oh,
right?
we would just have to go around, huh?
Yeah, you got to go back the other way.
Yeah. Mm, 18.4 plus 17 plus 21.9 plus 20.5. I got 77.8.
Yes. Yes, that's what I got here. Sorry, sometimes I'm looking at other problems, the next problems and other
Mhm.
things. So yes, sounds good. Any questions on it? Any
No,
okay,
pretty straightforward.
right, like hearing that. Okay, new problem to look at. They only give you one angle, and they're like, you gotta find this other one. It's like, oh my gosh, how am I gonna do that? There are a couple ways to do this. The one thing I'm drawn to is this triangle in here is an isosceles triangle. The one where the 63 is at the base here.
How do you
How do I know
how do
that,
you
right?
know that?
Well, these are both radii. We don't know
Um,
what it is, but we know they're the same. So that
mhm,
allows you to safely say the other angle is 63, but more importantly, this other angle here is
mhm.
180 minus 63 minus 63. I think is 54 degrees. Now, why does that help? Well, this other triangle is a
Is
right
a
triangle.
90.
Yeah,
Mhm.
and now that we have the 54, we know that this is 180 minus 90 minus 54, or 26 degrees.
Nice.
All right, 14.
Mm,
This is kind of the same problem, but in reverse. You want to first look at the large triangle.
mhm,
This is 90. So you can find this other angle is 46 degrees.
mhm.
And then that angle, if you want to go back to kind of this little one here, that's 46, that's 46 again, because it's a
Oh,
isosceles
they're both
triangle.
radio.
Yeah. And that allows you to find the other one.
$88 degrees.
Yes, very good. So this technique of drawing, partial drawings or removing a line is one, I would have emphasized a lot in if we had worked earlier in their course. Sometimes they're just
Mhm.
distracting to have so much going on. Okay. Yeah, this is always tough when there's just one angle that's given, because that means there's a bunch of things you're supposed to know here.
Mhm.
There's a couple ways to do this. There actually is a formula for this, but I think the way they're asking you to do this is to recognize that these are 90-degree angles here.
Oh yeah, I missed
And
that.
so in a four-sided polygon, quadrilateral, the sum of the interior angles is 360, but we already have three of them. We already have the 117, we already have the
Mhm.
90, we already have the other 90, and that equals X.
297.
Be careful there.
Oh wait.
Try that one more time here. Should be much smaller than that.
Yeah. 63. Nice.
Okay.
Mm.
You want to try 16 on your own? See what you come up with?
Yeah. I got 104.
I believe that is correct. Yes, 104.
All right.
All right. So do you have some other things you'd like us to work on today?
Uh, that was it. That's all I got today.
All right. Couple options here. I mean, obviously we could stop the lesson here. If you'd like, we could also do some SAT prep, or if there's anything else I can help you with in the next, little bit of time. Does any of that sound appealing to you, or, totally up to you.
Uh,
You're right.
that's okay. I mean, I feel pretty good about this, and so I think for today, that's pretty good.
Okay. We can absolutely stop here. So let me stop the recording here and wish you well.